So thanks for coming today. It's going to be a pretty good class day. Before we jump into the material too much, I do want to go over a couple quick announcements. I want to provide some clarification over the assignment for the discussion. Basically, for the financial analysis section, you're just basically approaching it as though you're convincing me as though I'm your boss or your classmates or your boss, and you're saying this is why we should or should not invest in whatever technology you're presenting. So just kind of finding some sort of financial figures. You got a lot of flexibility for how exactly you go about it. You know, there's no right or wrong answer necessarily. Well, there could be wrong answers, you know, but there's no singular right answer, I should say. So that just kind of provides some information over what that's kind of regarding. Any questions about the financial analysis section or any section that we covered for the discussion? Who's presenting Monday or tomorrow rather, or not tomorrow, Friday? We've got some people presenting chapter 1, I think, tomorrow or Friday. You are? You ready for it? You got any questions? All right, well, certainly, you know, if you come up with any questions, let me know. I didn't mean to put you on the spot like that, but you'll do great. You'll do great. Another thing I want to go over, if you've had me before, you probably know I like to give extra credit. This class is no exception. So I'm going to give you 2 options to do extra credit. If you attend in person, you know, you can certainly, you know, if I ask a question or whatever, you want to share something, I'll give you extra credit for that. Or alternatively, after class, I will post just something where you can reply to on Teams. You can do that if you attend the live person lecture, or if you attend it virtually, you can do it as well. Of course, if you're watching on YouTube after the fact, basically, you'll have until midnight on the day of the lecture to respond to it. If you either respond or if you say something in class, you know, provide some sort of discussion, then you'll get 2 points on your final, or not final, should be more clear. You'll get 2 points on the chapter exam. So for example, really unit exam. So for each of the different chapters, we'll have chapter 1, chapter 2, and I believe chapter 7 as well. If you participate in the discussion in either of those 2 ways, you'll get 2 points, and those can stack. So if you participate in today's discussion, you'll get 2 points. The max you can get per lecture is 2. So if you participate 20 times today, that's great, but you still only get 2 points. If you participate 1 time, you get 2 points as well. So if you attend in person or on Teams, you have 2 options there. Apart from that, you know, if you're catching the lecture after the fact, you have 1 option. But just want to make sure that everyone has the opportunity to participate in, you know, some sort of discussion. Just kind of have some good feedback. Does that sound good to everybody? Anyone not like that? I've never had a student not like extra credit. I just want to ask to make sure, though. So if there's any sort of questions, Ethan, do you have a question? Not sure if he's trying to say something or not. It's in the team. All right. Yeah, so I thought he was trying to say something. Anyway. That's okay. Certainly, you know, I thought he might have had some. Anyway, you get the point. So today, we're going to be covering chapter 1. And, you know, when we talk about data, it's important to first consider, why do we have a database? You know, why do organizations need data? Why would an organization want to have information? You know, what sorts of things are they going to do with the data, and what sorts of things are they going to do with the information? How do they build knowledge? How do they share the knowledge? How do they store knowledge? All these are the things we're going to be answering today. It's going to start off a little bit basic. If you look at the syllabus, not syllabus, but the schedule, you'll see today we're covering chapter 1. Monday we'll cover chapter 2. Wednesday we'll cover chapter 3. We'll do some exercises in class on the next Monday after that. That's the 31st of August. Then we'll have a review for the exam on the Wednesday, which is September 2nd. And then Friday, you'll have the exam. You can do that whenever you like, so within the window. So I understand a lot of people don't like Friday exams, so I'm going to open it up on Thursday at noon. So 12:01 p.m. on noon on that Thursday before. That's the 3rd of September. And it'll be closed on the 4th of September at midnight. So take it somewhere in that 36-hour window, and you'll be in a good spot. If you don't take it during that window, you basically will have 2 options. Your first option is to just replace that 0 with your final. So if you don't take one of the exams, you can do that. The other option would be to speak with me one-on-one and basically work out some sort of deal where I grade an essay or possibly a project. Probably don't want to do either of those two options. The best option is just to take the exams at regularly scheduled times, certainly. Any questions about anything? All right. Well, that's a lot of the kind of announcements out of the way, so let's go ahead and jump into this. So when we're talking about data, it's important to remember what data are. They're just individual points of interest. So we talk about you as an individual. You have individual data points that are of interest to you. So this is going to be things that you keep within your head. That's going to be your internal memory. And, maybe you're like me and you don't remember every single thing. So you have external aids that assist you in remembering things. The book uses the example of the calendar appointment. So you have a calendar system. And as you can see here, this helps you organize your life. It helps you organize your day, helps you organize your week, whatever the case may be. You're going to have certain data points within this. So you can see here, looks like this person has a lunch, an afternoon nap, and a bird watching. That's not my schedule, I can promise you that. Quite a bit more things going on than watching birds outside. But if you watch birds, this is scheduled. So there is a time and a day that this is happening. That's a data point. So each of these things up here. And, in addition to that, these are also ordered. So first, this person's going to go eat lunch. Then they're going to take a nap. I guess they're going to have a pretty big lunch, maybe. I'm not sure. But they're going to go to sleep afterwards for, looks like, maybe 2 hours, an hour and a half or so. They're going to wake up and start watching birds. That's what they're doing. So it has an order, and this is something that can be accessed at a relatively rapid rate. However, it's going to be accessed less rapidly than if you had these events memorized. So right now, you have to open up the app to see your calendar. But if you just jot off, I have these things, that's going to be quicker. That's internal memory. This is external memory. Same thing with an address book. How many phone numbers do you guys have memorized? Someone tell me. 2? All right, let me get you guys names for the extra credit. What's your... And who else answered? Ben. There's like 3 Bens in here, I think. What's your last name? Santiago. Great answers. So, you don't have very many phone numbers memorized. You may have more than that. I could probably think of 3 or 4, not to brag and try to one-up you guys or anything, but I probably could. So the whole concept is that that's going to be data that you're probably not going to have memorized. It's going to be stored externally. If you wanted to call someone, simply use their number. So the whole premise is that we want to be able to access this information at a very rapid rate. Now, imagine if I had all the numbers that I needed written down. Would I be able to access them very rapidly if they're written down? If I had like some sort of a planner, some sort of a booklet with all my information, would I be able to access that? You don't think so? Well, it's possible, but it's a lot easier to search. And what's your name, by the way? William Parks. I got to get better at names. Certainly, participation, 2 points is a good thing to do. So, it's important that we have the information in a way that we can easily find what we're looking for at a rapid rate. I probably have a couple hundred contacts. I'm assuming most of you probably have about the same amount. I don't remember the people I even have in my address book, much less what their address is and all that sort of information is. I don't have it memorized, but I can get to it very quickly. That's the point of an effective database. So same thing with a to-do list. You have some sort of structure. You can easily see what's going on. Now, this is going to kind of differ from when we think about this in organizational context. So obviously, businesses have lots of data. Obviously, they need a way to access it very quickly. And obviously, no single employee can memorize every data point that the company needs for their operations. So we kind of mitigate that by using things like a database. And this is going to be where we're in the external category. Internal is stuff that the employees have memorized. External is stuff that is stored in some permanent fashion. So that's pretty much the difference there. And basically, the whole concept is we have things that are important to our organization, and that is what we're going to have. This could be things like transaction history. This could be things like our financial information. How much money do we have in different accounts? What do we have that is sitting inside of accounts receivable? Are we losing lots of money by people not paying their bills to us? Those are things we'd want to know. So, with this, we really have a couple options. We can store it on paper. That's going to have quite a few drawbacks. We could store it in a database. We could store it in a local database. We could store it in a cloud-hosted database. We've got several options. And each of these are going to have advantages and disadvantages. Can anyone tell me an advantage of storing things on paper? There might be a few. And who said none? What's your name again? Kate. Yeah, I mean, there's not going to be many for a large organization, but for a smaller organization, I think it could be fair to say we'll have some advantages. What do you think? Can't be hacked, okay. Can be stolen, but certainly you have to be there to steal it. What, paper? That'd be a lot of paper, but I guess that's depending on the volume. Depending on the volume, that's a good point. And Justin, right? Gotcha. Trying to learn. What are some other advantages? Okay. The technological failure doesn't affect paper. Maybe some misplaced lighter fluid or whatever, that could be a problem. But, paper is not necessarily going to be the most usable thing. It's not going to allow us to rapidly run queries. It's not going to allow us to, easily determine what information we have. We have to be very familiar with it. Whereas with a database, we can easily run queries. We can easily see how many sales we've had for a period. We can break it down and get even more granular than that. We can see how many sales a particular salesperson has for this week. We can see how many sales a particular product has. Lots of different options that we have. And the whole concept is that these also are going to integrate within our information systems. So, we talked in 3233. You probably remember some of the different types of information systems that we had. So we had a transaction processing system, our transactions going through it. We had an ERP, which is a culmination of several different functional organizations within an organization, and really kind of helps us, tie all this in together into a singular system. Now, a database is great because it can interact with not just one system. It's not tied in. There's no vendor lock-in with a database, at least in most cases. There's exceptions to that. For the most part, though, when we think about a database, it's not going to be tied into one specific vendor's product. It's going to be allowing us to access the information using things like SQL, using things like extensible markup language. Those are going to be very beneficial for us. So just kind of recap on some of these. Decision support system, it's going to be where we have a system in place that's going to kind of help us out with decision-making process. So maybe instead of having, some decision be made, just flipping a coin, we, account for several variables that we think are interesting and we think, help us make more informed decisions. That's really the whole concept behind a DSS. Some of these others, there's certainly lots of them, but main two on here are going to be transaction processing system, which we've talked about, as well as decision support system. Let's talk about the information system cycle. So we've kind of discussed we have lots of information, we have lots of data within an organization. Why is that? Why do we have data points in an organization? Because we're doing stuff. We have clients that are purchasing stuff from us. We ourselves are purchasing stuff from suppliers. Maybe some sort of business-to-business transaction. We're hiring people. We're doing other things with employees that we have. Maybe we're downsizing. Maybe we're moving people. We have lots of different actions that are happening with our human resources side. And then we also have things like what quantities do we have of different products. So all these are going to be inside the present. So we have transactions that take place. Maybe we purchase something. Maybe something is purchased from us. Whatever the case may be, we want to store information about that. So we're going to do that right here inside of a database. Whatever the transaction is, we're going to store it permanently. And then that becomes data. And then with the data, we want to analyze it. So we're not going to cover so much of the analysis in this class. We will cover some queries and some of the different options we have to easily determine characteristics of our data. But we're not necessarily going to get into data visualization so much. We're not necessarily going to cover a whole lot of things about, quantitative analysis. That's covered in other classes, but that's what we're doing with the data. So we're having the database, we're going to use it, and then with that, we can determine how should we best run our company? What sorts of new systems should we have? Do we need to adjust our business processes to make things more efficient? Do we need to make things with higher quality? Imagine we're a manufacturing firm and we have information that suggests that we're not making things very well. So in other words, we're getting a lot of returns on a certain product. That would be data that we have. We'd run a query. We'd say, how many returns are we getting per product? How many products are we selling? What's the proportion of faulty products? And that's all that we're going to be doing. So that's the whole cycle. Any questions so far? All right. Like I said, today is a pretty self-explanatory kind of basic day, but it's important to understand why businesses would use data. So again, here's some examples of some fundamental systems. So we have up here, different processes. We want to do things like make sure that we're having efficient production lines, make sure we're not having a lot of waste. Any sort of place we can improve, we want to have the data to be able to aid us in that process. Things like remembering, recording. We do that inside of a database. Any sort of data point that we have, pretty self-explanatory to say we're going to put it within a database. So that's just some of the things. Now, within inside of this, it's important that we kind of keep in mind what are our goals. What is an effective database? Well, these are what an effective database are going to be. It's going to be shareable. In other words, it's not going to be tied in to one specific system. So if we think about a traditional information system, thinking back to well before the 90s, it would be very possible that we'd have one specific vendor and the data will be tied into that specific vendor's product or service. So if I had a piece of software, the data would not be accessible outside of that specific software. Databases make the data a lot more easy to share. They make it a lot more easy to be transported between systems, transported between firms. That's, of course, also a potential concern. So, if you do a simple query, you do select star from, all of your tables, then you have access to pretty much everything that the company has. That's both good and bad. It could be misused, of course. Imagine if you did select star from your employees table. And of course, the star is just the symbol for all. So you're selecting everything. You're getting people's social security numbers, their addresses. You're getting their phone numbers, their contact information. That's pretty sensitive information. So you'd want to have security measures in place as well to prevent people from doing that. So, in addition to having these things, we want to make sure that we have things like data sanitation happening. Whenever we're inputting information, people cannot do those sorts of injection attacks like I just described. Making sure the data is accurate. We can do that in a lot of different ways. Probably some of the common ways will be things like making sure we have validation of the data. So we have validation rules in place so that if we're inputting maybe a zip code, you can't input letters or you can't input symbols. You can only input 0 through 9 because each of the characters that we input should be 0 through 9 for a zip code. Making sure the information is timely. We don't want to have a lot of delays inside of the data. So if we're having to wait for the end of the week to get our data, that's not fast enough in some cases. There could be exceptions, but in most cases, we want to make sure that we're getting our data at a very rapid rate. We don't want to have large amounts of delays because if we are, it's not going to be as relevant to us. So when we think about data relevancy, it's making sure that we have information that can be beneficial to making decisions in real time, making sure that we can better understand our customers, making sure we can better understand what products and services we have. That's really the whole goal with this, is to make sure that we have information that is usable by our organization. Questions about these? Certainly feel free to stop me with any questions. So within this, we have different kind of ways to store organizational memory. So we have people. Now, when we think about what does a person really know? What do you know? All right, who said that? All right, it was okay. So about Mississippi State in particular, what do you know about it? It is. What are its colors? That's exactly right. So that's some things you know. What do you know about the culture of the college that you're in? College of Business. Someone answer that for me. Anyone? Is it the same as the culture of the College of Engineering? Same as the culture of the College of Education? Do we have a College of Education? I'm not actually sure. You know, there's going to be differences inside of culture within something. So let's go ahead and pause and kind of have a discussion. Does organizational culture exist? Why or why not? Why do you say so?
There's a whole lot of people in it, and culture by that.
Okay, and what's your name again? Damien? Gotcha. Just want to remind everyone, I'm giving out extra credit if you answer. So who says it doesn't exist? Who says organizational culture does not exist? There's a big debate in the business community right now as to whether or not organizational culture exists. And the debate really centers around the concept of organizational culture. An organization is very large. So for it to have a central culture is unlikely. What you're more likely to see is a team culture. You know, you may have a culture within information systems students. You may have a culture within accounting students, but you're less likely to see an overall culture within Mississippi State students. I'm not saying I agree or disagree with that. That's the argument, is that it's more team-based. It's people who you interact with more often than not. Anyone have a job right now? What do you do? Okay, so do you work in a team? Is it how many employees does this company have? Okay, so what about overall? Do you know? So, you know, I mean, there's probably more than 7 overall, though, I'd say.
Yeah.
So, you know, within that, do you feel as though there's a single culture for the Starkville location, or is there a company culture, would you say?
I guess there'd be probably more because
Yeah, so there's a lot of different ways to think about it. What's your name again? Ben Sanders. Appreciate it, Ben. Yeah, so anyone else want to share? Yeah. Okay. And how many employees are there? Okay, not the largest organization. That's all right. So would you say you and your boss have a culture? Okay. I mean, that's you know, you don't have to have a culture. That's certainly fine as well. I mean, it really depends on the organization. You know, some organizations may have a very well-established organizational culture. A company like IBM, it's been around for over 100 years, right? You know, Big Blue. What is their organizational culture? It's from what I understand, it's very hierarchical. You know, they kind of adhere to norms that have been established long ago, and that's kind of what they're known for. Now, I'm not saying that is true or not true, but that's a common kind of the common take on IBM. So there are other companies that probably don't have that. So it just really depends. Got sidetracked a little bit there, but that's all right. So we also have textual data that we want to store. That's things like different tables. So we have textual data. We have maybe things like a website. We have information on that. We have different documents we want to store. That's certainly other things we would have. We have different multimedia. You know, of course, we all know what multimedia is. Different images, video files, stuff like that. We have models. Now, we're talking about models inside of this context. We're talking about some sort of a business model, you know, some sort of equation, maybe something that we can say, this is why our organization does what it does. And then, of course, we have knowledge. There's 2 types of knowledge. Can anyone remember what those 2 types of knowledge are? Not from today, just the 2 main types of knowledge we talk about. So there's explicit knowledge and then there's tacit knowledge. So tacit knowledge would go more with people. So tacit knowledge are things like experiences, or things like a gut feeling that you have, you know, something that you gain, you know, just from experience, basically. And then explicit knowledge is things we can specifically write down. So for example, I could write down a grade. That's explicit knowledge. I could feel like a student is doing well. That's tacit knowledge. Is everyone clear on that? Okay. Yeah, certainly. I mean, it's more focused on, you know, kind of things that you would gain from having done something for a while. That's a great point. Yeah, it could be an assumption. I mean, certainly, it's like, you know, you feel something like that. That's tacit knowledge. And what's your name, by the way? Samuel. Make sure that I'm getting everyone down, learning all the names. Great point. Any question about this? So we talk about people a little bit more. You know, they say that people are the linchpin of an organization. They keep everything on track. You know, if we have a linchpin inside of a wheel, what does it do? Keeps the wheel from spinning off the axle. You know, so people really ensure that our organization is, you know, making use of the data in an appropriate fashion. Simply collecting data doesn't do us a whole lot of good if we're not using it. You know, imagine if I were up here lecturing and no one were here. No one were watching via Teams. No one ever watched my YouTube channel. That wouldn't do a whole lot of good. But because people do hopefully participate, they do hopefully attend, then that makes it useful. So it's going to be comprised of several things. But we kind of talk about what organizational culture is. This goes back to that discussion. You know, organizations are made of individuals. So individuals comprise the organization culture. If you believe that organizational culture exists, you don't have to believe it exists. There's certainly lots of arguments either way. You can read a lot of the stuff in places like Wall Street Journal, Harvard Business Review. You got lots of options for that. But if you believe that organizational culture exists, then you would say that people are the driver of it. So they kind of determine how are we going to best use any sort of information that we have. So, of course, another component of this can be a table. Now, what type of knowledge is on this table? Explicit, exactly correct. I think I have you down, Radona Maxwell. What's your last name? Exactly correct. Yeah, this is explicit knowledge. We can certainly record it easily. You know, I don't have to write a chapter on how I feel about the knowledge. This is the knowledge. This is the explicit knowledge. So a table, of course, is going to be comprised of two things. It's going to be comprised of rows and columns. And we see our columns here. That's going to be our variables. If we're thinking about this in terms of an entity relationship diagram, those are our attributes. We have an attribute for product. We have an attribute for price. And then within that, we have individual records, individual rows. Those are what we're actually keeping track of. So here we have a compass for $10. We have a geopositioning system for $500. That's a little pricey, I think, but I doubt this was written yesterday, so certainly keep that in mind. That's what a table is. You know, we don't just limit ourselves to tables, though. So we want to be able to get information out. We use a report for that. So we have some predefined things, or we could go on the fly. We could certainly do an ad hoc report where we don't have anything predefined. We determine what information we need, and then we run a query, and we pull down that information. That's certainly within what we could do. Of course, we could put this information in a lot of different places. We could write a product manual. You know, that's certainly one option. Put it on a brochure, email. You get the point. Once you've gotten the information from a report of some sort, you can do whatever you want to with it. It's yours. You can mail it out to everyone on your contacts list. You could give everyone a personal phone call. I don't know why you would, but you could. It's within the realm of what you could do. So we talk about multimedia. We've pretty much covered these. It's just, how do we store these? You know, well, we have to store them physically. We have to store them on a server. We have to store them on a computer. We have lots of different options for how we can go about this. The whole concept is that we have these options. You know, we can do a video. You know, that's certainly within what we are able to do. Of course, we talked about the models. Kind of went over these as well. It's going to help us make better decisions. You know, so we're going to have different mathematical models maybe that are important to us. We're going to have things like a spreadsheet. What are some other models we may have as a company? Okay, and what would the charter graph have on it? Okay, so some sort of profitability chart by product. Great answer. What else could we have for a model? The cost-benefit analysis. That could certainly be a model we could easily do. And give me an example of a cost-benefit analysis. That's exactly right. And what's your name again? David Banks. I've got to be better at learning names. I'm getting there. Don't worry, guys. Yeah, those are great models we could have. We've talked about knowledge. You know, we have things that we store. Knowledge, of course, being the interpretation of information. So at the most basic level, we have data. That's the raw data points. It's basically information that has not been processed at all. It's, you know, typically going to be explicit. And then we process it in some way. That's going to be information. So we could do information about what sales we have. We could do information about just lots of different things we could have there. And then when we actually apply it, that's knowledge. So that's the kind of understanding there. We've talked about decisions. You know, lots of different types of decisions. What are the two main types of decisions that we have when we follow something like Gorey and Morton's model? Anyone remember those? There's actually three, but there's really two that we focus on. So at the top, we have structured decisions. These are decisions that we know the specific inputs that we need to have, and we know what we're going to get from them. This is going to be things that are, I'm not going to say we have 100% understanding of. We have a pretty good idea of what will happen. And that's going to contrast with an unstructured decision. So an unstructured decision, we have a lot of ambiguity. We don't know specifically what all the inputs should be to determine what the result will be. So for example, if we're making a new site, is that a structured decision or an unstructured decision? We're doing site selection. Typically, we think of that as being an unstructured decision because we don't truly know what will happen with our new site until it's there. That's going to contrast with something like, do we issue a loan or not? You know, to an individual. That's going to be a highly structured decision. We have a very good understanding of, with these specific parameters, what the result will be. So that's the two main things there with decisions. We can also get into more specialized memories. This is where we're talking about things that, you know, kind of relate to your senses. So if you think back to specific smell, it may trigger some sort of a specialized memory. Anyone want to share an example of this? Hopefully a pleasant example. Very cool. I never heard of vanilla bark, but I'll have to check that out sometime. Any other examples? Yeah, I mean, oh, popcorn. What does that remind you of? Movies, fair. Man, you guys remember when we could we used to be able to go to movie theaters? I feel like I'm a member berry up here. Member? Yeah, you get the point. You know, a lot of what we talked about today are things that are external to the organization. You know, and then we also talk about some things that are internal to the organization as well. We talk about, you know, specific external memories. That could be things like our competitors' sales. It could be things like what is not within our organization. So it could be anything like that. And then we talk about things that are within our organization. It's what our organization is doing. So just kind of clarify on that distinction there. Pretty much. Then we have different problems we could have. So I wouldn't necessarily limit this to data management. These are just general problems that you could have with any sort of system that you're using. So specifically, though, data, we don't want to repeat the data. We don't want to have any sort of redundancy. If we have redundancy, what's the problem with that? Well, it costs more storage space. If I store the same information 500 times, I wasted 500 times more storage than I needed to. That costs money. Could also slow down processing. If you have to process something over and over, that could certainly take more time, and it could take a more beefy system to do so. Either one of those things are bad. Also factor in electricity usage. You know, if you're spending 500 times more time processing, that's 500 times more electricity to get the same end result. You want to avoid redundancy. Not having good data control. That would be a system where once the data is in there, we cannot change it whatsoever. That's both good and bad. If we think about, do we want every single person to be able to change every single point of data? Hopefully no one says yes. If that's the case, then we don't have good data accuracy. We don't have good data integrity. We cannot be assured that whatever data we have is accurate if we don't have good data controls in place. Having a poor interface. Again, this is not limited to just the database, but if we're unable to easily interact with a system, it's not going to be used very much. People are going to find workarounds. And there's a lot of work on, when people actually follow policies versus when do they find some sort of workaround versus when do they not comply at all. So that's kind of what this is talking about. If we don't make the system easy to interact with, why would anyone interact with it? Having some sort of delays. We talked about, what causes delays within a database. Well, really two things: lack of processing power, or having excessive information that we don't need. Those are the two things that are going to cause delays. Lack of reality kind of goes back to making sure we have accurate data. If our data are fabricated, then what's the point of having it? We don't want to have that. Then also having lack of data integration. Again, the whole purpose of a database is that we can easily interact with it across different systems. We're not limited to one specific product. We're not limited to one specific piece of software. We have lots of flexibility for how we interact with it. So here's just a brief timeline. I'm certainly not going to test you over these different things here. So let's just kind of focus on what we're seeing here. Relational databases began in 1972, 48 years ago. We're still talking about them today. Is that good or bad? Well, I guess I think it's good. Does anyone think it's bad? I mean, it's both good and bad. There's always going to be pros and cons to everything. We talk about a relational database model. Has not changed since 1970. COD came out with a paper, talked about here's what the relational data model should look like. Here's some of the characteristics of it. That has not changed at the most basic level. Then we kind of contrast that. Now we're, I wouldn't say moving away from, but there's increasing adoption of non-relational models, non-relational databases, rather. And these are things like NoSQL, MongoDB, those sorts of things. And a company would do that because it has less overhead for processing. If you have, just billions of transactions happening on a day basis, it's very difficult to put that inside of a relational data model. There's a lot more processing overhead with a relational approach than there would be with a non-relational approach. So we're not going to focus too much on that in this class, but that's kind of why we're starting to see the emergence of these non-relational data models. I also think it's kind of funny that all these end in 2017. That's not the case. These are still used today. Certainly don't take that 2017 as saying, well, we're 4 years too late. You're not. So we talked about data. Here's an example of some data we could see. So we see here this is a table. And within the table, we have lots of different data points. So it looks like we have some different things here. We have a column for case number. We have a column for name, different procedures there. So that's what we're looking at within this. And this is basically completely raw. We haven't done any processing on it. We don't know who has had which procedures done. We don't know that. But once we begin to process it, we'll form information. That's when we'll actually see, how many people have had this procedure. That's certainly something we could do. That's information. Here they're correlating several different variables together. That's giving you information. Then we take that a step further. You apply that information to, some sort of problem, some sort of knowledge. That's when you get the knowledge. So, having the information is not inherently knowledge. You apply it, it becomes knowledge. Does that make sense to everybody? Okay. So here's this in a kind of more visual format here. So we start off, we get data. That's the things like transactions we've talked about. What's some other examples of data we haven't talked about? Someone throw something at me. Not literally. So, data is just anything that we're getting. What do you think? Reviews on a product. That's a great example. And Xander. Any other examples of data? You said binary? For what specifically are you talking? Just random binary data points. Okay. Could be. What's your name? Tommy. Gotcha. Either way, I'll certainly make sure to find you when I'm putting the points in, of course. That's what I'm talking about. Yeah, so those are great examples of data. Then we convert that. We do some sort of processing on it. This could be maybe adding them together, maybe taking an average, maybe taking some sort of division, finding out some sort of ratio, whatever the case may be. We're forming information. We use that information to give us, some sort of advantage, possibly. I don't want to be bogged down by thinking about competitive advantage or any sort of strategy, but we use that information to make better decisions. Let's say that. That's when we get knowledge. So we can request information to inform us of knowledge. We use that interpretation. We make the better decisions. So that's what this whole chapter is about. Like I said, it starts off a little bit basic. We'll cover some more stuff. Chapter 2, kind of relating to some of this. And then Chapter 7, we'll start doing some data modeling. So basically, the whole goal is that we have just tremendous amounts of information. We have tremendous amounts of data. We have to make sense of it. And there's lots of different ways we can go about that. But the whole concept is that with SQL, we can easily run queries. We can easily exchange information from one system to another. And we just have lots of flexibility for how we go about things. Any questions? All right, let me make sure I didn't miss anything in the chat of Teams before we wrap up. Okay, looks like there's a little bit here. Yeah, that's about it. I'm going to go ahead and stop the recording.